Welcome to the workshop, Get Real-Time Insights into Machine Learning Model Training with Amazon SageMaker Debugger. My name is Nathalie. I'm an applied scientist at AWS, and I'm going to present this session together with Lou and Satadal, who are the product managers of SageMaker Debugger. So first, I would like to start with a high-level overview of the agenda. In the beginning, I will give a brief overview of what debugging in the machine learning lifecycle means. And then I will go deep into the typical issues that occur when you try to train machine learning models. Then Satadal will take over and show us how you can use SageMaker Debugger to very easily and automatically identify issues in your model training. And then in the end, we will show a few demos. We will show one demo where we will showcase SageMaker Debugger and how it can help you to find critical model bugs in your deep learning models. And Lou will show us a demo where you can use Debugger for XGBoost model training. So what is debugging in the machine learning lifecycle? When we do machine learning, then it's not just about creating a machine learning model, but we have to take care of a lot of different steps. The first step in the process is data preparation, and it's one of the most important ones, because if you're not having high quality training data, then your model will not achieve a decent accuracy. And there are many different things we have to take care of. For instance, we have to do feature engineering, take care of missing features. We have to do data preprocessing, and debugging at this stage should help us to detect data-related issues. For instance, whether the data was correctly or incorrectly normalized, and issues such as class imbalance. Once we have good and high-quality training data, we can start training the machine learning model. And typically, when you do that in an iterative process where you try out different model architectures, different hyperparameters, maybe different training data sets. And it's quite common that in this situation, you may run into the situation where you end up with models that are not generalizing or models that start under or overfitting. And trying to detect the root causes of such issues is not always easy, and it's very time consuming. On top of that, when you try to parallelize these kind of experiments, you want to be able to auto-terminate training jobs where you already know that they lead to a suboptimal model. Debugging at this stage should also help you to get model insights, trying to understand which kind of features is the model actually learning, and trying to see whether you maybe have to create better training data sets. Once you have a decent model available, the next step in the pipeline is to do hyperparameter tuning. And there, the goal is to find the best combination of hyperparameters for your model that can greatly affect the overall performance of your model. And it's very common that you may end up with a set of hyperparameters that lead to a model that just does not generalize, or maybe the training just doesn't converge. And again, you want to be able to automatically detect that and also auto-terminate tuning jobs that lead to suboptimal results. Once you have a tuned model, you are ready to deploy it. And when your model goes into production, then issues you may run into is, for instance, data drift. That means that the distribution you trained your model on and the distribution your model sees during inference are not the same. And it's very common that the model will not do good predictions anymore if this happens. And debugging at this stage should help you to understand incorrect predictions, trying to understand what went wrong. So now I would like to dive a bit deeper into the different problems. So very commonly, it may happen that when you train your machine learning model, that you may end up with a model that is, for instance, underfitting. So basically, you train a validation loss just does not converge at all. Or your model maybe starts overfitting, so it learns very well the training data, but it is not able to predict the data it has never seen during training. So basically, the validation loss is high. And very commonly, you may run into this situation, and trying to find the root cause of such problems is not easy. Some of the problems you may run into, for instance, is data-related issues. As I have shown in the beginning, this can happen when you have, for instance, class imbalance. For instance, imagine you have two image classes, and one image class, you have 1,000 examples, and for the second image class, you only have 10 examples. If you're not taking care of that during your model training, then what will likely happen is that your model will have very low predictive power for the image classes with fewer instances. On top of that, when you train your model, especially for deep neural networks, you have to take care that you shuffle and randomize the data. If you don't do that, it's very likely your model may start overfitting because it learns kind of dependencies between the data in the data batch, and you should avoid that. Data preprocessing is very important. So typically, you need to ensure that you have zero mean and unit variance in your data. So when you scale the features, it basically allows you later on during the training that your model can more easily converge. If you have features that have very large scales, like in this image here, then basically your training is kind of overfitting on that feature. And data preprocessing helps you to get a smoother space where your training can more easily converge. When you train deep neural networks, then you have to choose activation functions that basically decide whether your neuron will be activated or not. There are different types which are available, like linear activations, tangent, sigmoid, relo activation, and some of them come with certain problems. Problems such as neuron saturation. Neuron saturation happens when you have activation functions such as linear or tanh, and what happens is they have asymptotic bounds. So if your weights are pushing now your activation function towards these asymptotic bounds, you get vanishing gradients. And when you have vanishing gradients, your parameters won't be updated anymore, and your model cannot effectively learn if you have too many neurons in your model that suffer from that problem. In deep neural networks, we have weights, and when we train these models from scratch, we have to initialize the weights. Different initializers exist, such as uniform, normal, Xavier initializers, and the goal is that you initialize all the weights to different values, because if you would not do it, what would happen is all the weights have the same constant value, they would receive the same gradients, the same updates, and your model does not learn. If you initialize it with values that are too small, you will get vanishing gradients. If you initialize it with values that are too large, you get exploding gradients. So in both scenarios, your model wouldn't really learn. And then you may be also interested in the weight updates to see if there are certain weights in your model that just never really get updated. When you train deep neural networks, you also have to choose an optimizer. There are optimizers like stochastic gradient descent, ADAM, RMS prop, ADACrop, and many more. And they can influence how fast your training will converge. Most of those optimizers take hyperparameters, such as learning rate, momentum, weight decay, and many others. And if you try to tune these hyperparameters, it's very easy to get it wrong. What may happen is if your learning rate is too small, your training will just not converge. If it's too high, your training may start oscillating. So choosing the right hyperparameter for your model is very important. Then in training deep neural networks, you have gradients, and they may vanish or explode, which can, for instance, happen with the activation functions or if your weights are incorrectly normalized. But it can also happen if your model has too many layers. And this animation here shows an example model that had more than 12 layers. And what happens is that during backpropagations, these gradients are, the signal is propagated back in the model, but if there are too many layers, then the layers that are further away have much lower gradients. So we see here in the distribution of the gradients that they differ quite a bit between the last and the first layer. And things you can do is, for instance, you can apply edge normalization, residual connection to kind of avoid these problems. Now I would like to hand over to Satadal, who will show us how you can use SageMaker Debugger to very easily find all these problems that I just demonstrated.
Hey, thanks, Nathalie. So before we get deep into SageMaker Debugger, let's look at what Amazon SageMaker as a service provides. So we built Amazon SageMaker as a fully managed service so that we can provide end-to-end machine learning services to enterprises. So if you can you please click to the next slide? Yeah, so if you look at the entire journey of a data scientist, there are different steps involved to go and train a model. The first step usually comes with collecting data and labeling them. It can be image some kind of textual data. But most often, when people are dealing with images, then you need to have a ground truth, and then you go and have a service by which you can do leveling. So we provide a service for leveling as part of Amazon SageMaker. Then once you have your data leveled, you go build and train the images. So you basically create a model by training, and there are different services Amazon SageMaker provides. And this will be our core focus of discussion today, since Debugger comes under build and train part. So we have different features or products as part of build and train. There is the Studio, which is the IDE. It's based on Jupyter Lab, which gives you an interface through which you can easily interact, visual interface, and you can consume all the different features of Amazon SageMaker if you choose to use your visual interface. So that's called Studio. The Debugger is a feature that we are going to go and talk much more deeper, which addresses the problems that Nathalie pointed out and makes it easy for you to literally use the Debugger to find issues for you. So we'll talk more about it. And then the other three things to point out quickly is Autopilot, which is basically AutoML, which is a very good way in which you can take a tabular set of data and point SageMaker to it, and it's going to go and train different kinds of models and point out the best model that is applicable for your data set. Then we have the notebooks, which is a very convenient way for you to start coding in your Python code and debug on the notebook itself. And you can consume all the features that SageMaker provides through Python SDK, through Notebook if you choose. And we have Notebook also integrated with Studio. And then finally, the experiments. Experiment is a feature which allows you to group different training trials. Think about it as a folder under which you group your training trials. So as you change your hyperparameters and you retrain your model, it's a convenient way for you to group all of these trials and compare what happened across the different trials. And the experiment is integrated with Studio, so you have a visual way of looking at a folder and then looking at all the trials that are underneath. Okay, let's proceed. So once you have built and trained, then obviously you want to make sure that you have done everything to tune and get the best performance out. So we have automatic model tuner, we have hyperparameter optimization built in Amazon SageMaker, which you can leverage to further tune your model to the desired accuracy and result that you're looking for. And then once you are done training and tuning, then now the time comes for deployment. So there's an additional feature in SageMaker called SageMaker Neo, which allows you to take a model and compile it. It's a deep learning compiler, and you can reduce the size of the model, and it also optimizes using different machine learning techniques to get a better, I would say, a better accuracy out of that model. So with SageMaker Neo, you can go and compile the model, and the output of that is generated will only have the relevant frameworks that your model requires or uses. And once that is done, you're ready to now use it, deploy it. So there are two ways in which you can do it. You can either deploy your model in cloud as a SageMaker endpoint, or you can choose to deploy it on edge device using a service called Greengrass. And then the last thing that I'd like to point out is that once you have deployed the model and you have an endpoint for it, we do have a service called Model Monitor, which allows you to look for drift and anomalies on the endpoint itself. So you have the whole cycle of build, train, deploy, and then you can go back and look at drift and anomalies, and you can go back to training. So it's that feedback loop. Next slide, please. Okay, so today we are going to focus on the debugger part, as I mentioned. So what is SageMaker Debugger? SageMaker Debugger is a fully managed service, which actually takes the undifferentiated work away from you in terms of instrumenting your training script to save the data that you care about. So I'll show you with just a few lines of code in your training script, you can save literally what you care about. If you're training a deep neural network model, you can save your weights, gradients, biases, and so on, or you can have your own custom collection of tensors. So the actual work of going and instrumenting TensorFlow, PyTorch, MXNet, or if you're using classical ML like XGBoost, that is done for you. So we have AWS version of TensorFlow, PyTorch, MXNet that is included in the training container in SageMaker, which has the instrumentation in the machine learning framework to be able to go and save the tensors that you care about. So that's what we call as capturing the relevant data with zero code change, because you're not changing your script to do that. We have done that work for you. And then once you know what you want to save, then the next thing is analyzing the data that is being saved. So that's where SageMaker Debugger comes with a set of what we call as built-in rules. These are basically conditions that Nathalie was pointing out in order to find different issues and detect them. So as a managed service, SageMaker Debugger is going to go and look at those analysis. It's going to stand up a separate container, and it's going to run the analysis on your behalf. And if we find issues like vanishing gradient and exploding tensors and class imbalances and so on, we're going to raise CloudWatch alert event. And you can basically take action to either stop the training or have an SMS or email sent across. So it helps in saving time and also doing parallel experimentation, knowing fully well that you don't have to go to the end of the training. You can basically stop the training ahead of time. It saves time and cost. And then once that detection and monitoring happens, again, remember, this is all happening at real time when the training is going on. We also provide a set of API or SDK. It's part of a library that comes with SageMaker Debugger called SMDebug, which allows you to do custom analysis in your notebook. So you can do your own custom plots if you want to dig deeper. And that also is part of the feature itself. And we have a series of examples that we have in GitHub under SageMaker examples directory, which shows you how to take the API and do your own custom analysis. I'll highly encourage you guys to check it out. And then finally, all of this is integrated with SageMaker Studio. So if you're using Studio, you will see that the CloudWatch events will surface when events trigger. You will have losses and accuracies collected on your behalf. And then you can plot that across multiple training trials to see how the trend was over multiple training trials when you ran. Are the losses decreasing or not? And so on. So it's a convenient way of seeing the output generated by Debugger in a visual way in Studio. Right, next slide, please. All right, let's talk about which frameworks are supported. So in SageMaker Debugger right now, we support both classical ML, XGBoost, as well as deep learning models, TensorFlow, MXNet, and PyTorch. So one thing I'd like to call out is that independent of which machine learning framework you're using, the interface of Debugger and the functionality is identical. So we kind of abstract away the machine learning framework of your choice, and we provide an unified interface to use and interact with the debugger. So the APIs are same. The way you enable collection of data and the output that you're getting is exactly identical. So it becomes much more convenient, and our customers love that because, frankly speaking, there are a lot of differences when it comes to TensorFlow, PyTorch, and the other frameworks. So it's a convenient way in which the managed service hides all of that from you. And we will keep adding new frameworks as they are released. Next slide, please. Okay, so the question was sklearn. So scikit-learn is very similar to XGBoost. So we have heard customers asking for scikit-learn as well. So we have that in our roadmap. So we will support that. So it's not there as of today, but it's coming pretty soon. So let's look at how this works. So as I mentioned, you can, with a few lines of code change, you can specify what you want to save. So the saving part happens on the training container. So here we have the training container, which our training is in progress. We save the data in your secured S3 bucket. So it always goes in your secured S3 bucket. You have full control over the data. SageMaker Debugger does not save any data anywhere outside, and we do not consume anything else. So I wanted to make it very, very clear. So you as customer will have full control over the data collected. And so we will collect the data in the training container, which will go in the S3 bucket, and then we'll read from it in a separate container so that it does not impact your training time. So the analysis part is entirely done in separate, fully managed containers that SageMaker Debugger will spin up. And in that, we will run those built-in rules, as we call it, which are the analysis. And there will be multiple of them. And they are going to run in parallel when the training is going on at real time. And if we hit any of these conditions, then we are going to raise CloudWatch alert event. And based on the alert event, you can take actions like stopping the training as we discussed. So next slide, please. Okay, yeah, and then you can consume the output from this through CloudWatch event, through notebooks, as we mentioned, and then finally through Studio. Those are 3 different ways in which you can consume the output of it. Next slide, please. Okay, so let's look at a quick example of this thing, on the benefit of SageMaker Debugger. So if you look at the top part, the data capture part is done by just a few lines of code. By what to say. In this particular case, we are saving gradients and ReLU. The gradients, as we all know, in a deep neural network is extremely important because it controls how your training learns over time. And the rectifier linear units are also extremely important because those are the ones by which you will know these are activation functions with which you will know whether how your neural. So in this case, we want to capture gradients. And the ReLU actually is something that we capture through a regular expression because these are not standard like weights bias gradients. So you say that, okay, I want to capture all rectifier linear units that are with conf v1 underscore ReLU. So that's how you specify that. Again, this is just an example. You can specify whichever tensor you care about using the regex function. And then what Debugger will do, it will take all the work of collecting all of that. You don't have to specify any code. It's all done for you, and it'll start collecting those, right? So you just need to specify what to collect, and we will start collecting on your behalf. Now, in order to read the data that is being collected, that's where the bottom part is. So as you can see, with the SMDebug library, we basically can read the data and put it into a NumPy array, and you can plot. And in this particular case, you can see that the histogram that is plotted, if you hit the return, let's get the graph out, Nathalie, then you'll see that over a period of time, in this particular example, where the training went from 0 to almost 18,000 steps, in the first 1,000 steps, the network was really learning because there was meaningful gradient values. But after that, the gradient became so small, the ReLU output became so small that your training is not really learning. So you basically want to. So that's where the rules come in. And you can basically say that, hey, if my threshold values goes beyond a particular threshold, then I want to stop the training. So essentially, you can save a lot of time and money if you can get insights like this, which you can see that Debugger can provide to you. I just wanted to highlight as well that the SMDebug library is open source. It's in PyPy, which has all the functions required to read and write. So it's basically foiling the Debugger functionality. So you feel free to check it out in PyPy as well. Next slide, please. Yeah, so this is basically a pictorial view of what happens when a rule gets triggered. Usually it returns true or false. So false is when there is no issue detected. True is when we detect an issue. And when we do detect an issue, at that time, you can write a Lambda function to take actions. We will have some pre-built actions already there, which will help you to just select what action you want to take. But if you want to do a custom action, you can do that as well. The most common action we see from customers is that if a threshold hits and the rule triggers, then I want to stop the training. Because at that time, it's a non-converging conditions, right? So that's very common. And that way you can start multiple experiments or trials in parallel and have different hyperparameter values in there. And then you have your rule triggered based on what you specify, and stop the ones that you don't care about, and then continue on with the one that has the right kind of values. So I think this is the last slide in my section, and I would like to hand it back to Nathalie to go through the demo.
Okay, thanks a lot for the overview of SageMaker Debugger. So before I jump into the demo, I would like to just quickly see if there are any questions from the audience. No questions so far? Okay, then let me go into the demo. Can everyone see my screen? Okay. So in this demo, I'm going to show you an example application where what I'm doing there is I'm taking a pre-trained ResNet model from the PyTorch model zoo, and I fine-tune it on a new task. The new task is to perform traffic sign classification. And the model has achieved initially a decent test accuracy of 92%. But nevertheless, I decided to run it with debugger built-in rules to just see how well is it actually training. So how this looks like in the notebook. So I'm here now in the SageMaker Studio environment. I have here access to all the experiments. So in this notebook, I'm basically now using the SageMaker Python SDK, and I'm selecting here the rule configs subpackage. And what you can do via this package, you can now access any of the available built-in rules. As a user, you will run those rules for free. And as I mentioned in my introduction, Debugger can capture most data from your model and can identify issues such as dataset-related issues, gradients, weights, activation functions. And the great feature about Debugger is also you can use it to auto-terminate your training job. So especially when you run in a situation where you already know that the model is underfitting or overfitting or just not generalizing, you actually really want to stop the training, because trying to train a model that runs into this issue would be wasted compute time. We also have a few built-in rules that are specific for XGBoost, and Lou will show us later on more about that. Now I'm just specifying the kind of rules I want to run. So I select here the class imbalance rule, the date railer rule, and loss not decreasing. For all these rules, you can on top of that specify rule parameters to tweak the rule for your specific use case. Then, as Satadal mentioned in the presentation, you can specify debugger hook configuration that basically tells debugger which kind of data to emit from your training. In my case, I'm defining a custom collection where I just specify via a regular expression the tensor names I want to have included. So in my case, I want to capture all activation outputs, the model inputs, the images, as well as the inputs and outputs of the loss function. And when I start my training, in SageMaker, you always have to define an estimator object, which you pass in the training script. So my training script here is basically doing the fine-tuning of the ResNet model. It defines the data loader and then the training loop. And now I just have to pass in all the configuration that I specified, the list of rules, the debugger hook configuration. And then when I call estimator fit here, what debugger will do is it will now take care to automatically emit the tensors from the training container. And then it will also spin up the rule containers that will now run the class imbalance rule, the date railing, and loss not decreasing rule. You can either use now the SageMaker Python SDK to check the rule status, or you can go in Studio to the experiment view. And then if you have not specified an experiment, you will find it under unassigned trials, and then you can just select it. So how this looks like here is, I can see here now the rule status. I see that 2 of the rules triggered, class imbalance, loss not decreasing. And what I can do now is, now I want to identify what has been happening in my model and why did these rules actually trigger. So as Satadal mentioned, you can use the SMDebug API to fetch and retrieve the data, and it's open source. The first step is always to create a trial object that basically takes the path to where the data is located. That can be either an Amazon S3 or it can be a local path. And once you have the trial object, you are ready to access and query the tensors. So I just want to show here a few functions that allow you basically to retrieve, for instance, the tensor names. So in my model, I retrieve now the first tensor names, which are the cross-entropy loss function, the different layers that Debugger captured. You can access the number of steps. A step in Debugger is one forward and backward path, and you can even distinguish now between steps that were recorded during training and during the validation phase. To do that, you just pass in here modes.eval. Then to get now access to the tensor itself, you just have to pass in the tensor name. You can get it from the list here, just pass in the name, and then this dot value, you access now the NumPy array at this specific step number. And now you can also just start iterating over a certain set of tensors by just defining a regular expression here. So with this easy to use API, I can now debug my model. The first thing is I want to investigate why did the loss not decreasing rule trigger. To do that, I can now use the function try.tensor, and Debugger has saved the inputs and the outputs of the loss function. So here I'm getting the outputs, and as dot values, I access all the values that have been recorded so far. This dictionary is automatically updated as your training is still in progress. So with just a few lines of code, I can quickly plot the loss curves, and I see that the rule triggered because after 1000 iteration, I did actually not improve the training loss anymore, so I could probably have stopped training. As Satadal mentioned, you can enable auto-termination, and I applied that on this specific rule, rerun the training, so I'm getting now a new try object, and I just plot both results. So after I have set up the CloudWatch alarm with the Lambda function, I rerun the training, and I see now that once my rule triggered, roughly after 1,500 iterations, the training stopped. So I was able to save more than a factor 2 of the training time just by enabling auto-termination. So we have also seen that the class imbalance rule triggered. And in order to investigate the issue, what you can do, you can now just get the inputs into your loss function, which are the labels and the predictions. And you just count how many class instances has your model seen throughout the entire training. To do that, I just specify here modes.train, and then I just count the labels. And what I see now in this plot is on the x-axis, I have the different image classes my model has been fine-tuned on. On the y-axis, I have the instance counts, and I see some images my model has seen less than 50 times, other image classes more than 250 times. And that's why the rule triggered. You can fix this issue by applying weighted random sampler in PyTorch, where you just identify the weights of the image classes, such that the data loader will sample more from the classes with fewer instances. Based on the class imbalance, I was interested to see if there is maybe an issue now with particular image classes that get predicted more often incorrectly. And to do that, I plot the confusion matrix. For the confusion matrix, I get now both inputs into the loss function, so the labels and the predictions, and I just put that into this function here, confusion matrix from scikit-learn. And what the confusion matrix now shows me is, on the x and y axis, I have the 43 image classes, and the first row will tell me how often was my image class 0 predicted as image class 0, and how often as 1, 2, 3, 4, and so on. Ideally, you want to have high counts on the diagonal because those are correctly predicted image classes. But we see that there are some outliers that could be caused by the class imbalance issue. So for instance, we see here that my class 8 has been a few times predicted as image class 2. And now I use Debugger to just analyze those incorrect predictions. I get the labels again, the predictions, and the model inputs. The model inputs are the image batches. So this is my model input. And in this few lines of code, I'm just trying to data mine where did my prediction not match the label and plot the corresponding image. And these few lines of code gave some interesting insight where I quickly realized that what my model always got wrong is whenever it had to predict a direction, it would kind of mix it up, like keep right and keep left. And the underlying root cause of that issue is that the user had applied during data augmentation a random horizontal flip that you typically use when you train ResNet models, but it's a big problem if you have a data set like that that involves some direction. So based on all this analysis, first, you can also write custom rules. So what I do here is I write a custom rule that detects for me how often did my model mix up those directions. I use a particular image class, turn right ahead, and count how often was it mistaken as turn left ahead or vice versa. So you can now just create your own custom rule. You have to implement the invoke it step function that takes tensors that will be run every time tensors of a new step are available. I fetch here the predictions and the labels, and I just check whether this particular image class is in the prediction or in the label. So in my case, this was image class 34 and 33. And whenever I see that they are predicted as one versus the other, I increase a counter. And if this happens more than 5 times, I want the rule to trigger because that tells me my model is doing something wrong with those directions. And you can run the rule locally outside of SageMaker. You just instantiate the rule class and call the function invoke rule. What I see now is the rule triggered at step 1494. And now I want to create this custom rule to run it as part of my SageMaker training. To do that, you just specify a rule configuration. This takes the definition of the rule, which I saved in a separate file. And you specify an image URI that is for the rule container, in which kind of container this should run. Now I basically fix and rerun the training script. I apply weighted resampling. So if I go to my training script, I basically define here the weighted resampler that I pass into the data loader. Then on top of that, I remove the random horizontal flip. Then furthermore, I decrease the number of epochs from 15 to 3 because I have seen that my loss not decreasing will trigger. And basically now I rerun the training like before, but this time with my custom rule that I defined here. So now that I rerun the training, I can go to the experiment view. And what I will see now is, I see now that none of the rules is triggering any longer. So class imbalance is fixed. The loss not decreasing rule doesn't trigger anymore because I applied early stopping, and my custom rule does not trigger either because I fixed the random horizontal flip. I can now also fetch the data and just see how well did I actually improve. So what I see here is these were from my previous training jobs where I had a class imbalance issue, and now after fixing the training script, I see that my label counts are now way more uniform and there is not an imbalance anymore. And then more importantly, we can now look at the final model metrics. My validation accuracy of my initial model was 95%. And in my new model that run in much less training time, I actually achieved 96%. So Debugger has helped me to increase the model accuracy, to find a critical model bug, and to improve and reduce the training time by more than a factor 2. So now I would like to go back to the slides, and I will hand over to Lou, who will show us how you can do similar analysis for XGBoost models.
Nathalie, can you guys see my screen? Looks like you can. Okay, so now I will show you guys a new feature we just released for supporting XGBoost model. So we all know that XGBoost model is has a fairly shorter training time. So what we are adding value for XGBoost training is we're providing you a automated and also interactive visualization at the end of your XGBoost training job if you are training on SageMaker. So we have a detailed documentation on how do you train using SageMaker API to train. I will share it here. If you look at if you use this documentation, you'll see like how do you use SageMaker API. And so SageMaker, so Debugger works for both for Studio and the Notebook. So what Nathalie showed you guys is the Studio version, and I'm going to show you guys the Notebook version. So what I'm doing here is, so I created a XGBoost model to predict churn rates, and here is the like where I set the hyperparameters, and then after that, I'm gonna train with debugger, and this is so basically you need to call the debugger API, and that's how we set up the debugger API. So if you refer to the documentation, it has very detailed step-by-step instructions. The advantage of using the debugger training API is debugger automatically handles all the resource provisioning related heavy lifting for you behind the scenes. So it automatically spring up like new instances and automatically shut down those instances at the end of your training job. So you don't need to worry about any of that. So here I'm basically calling the training API for my XGBoost job. And all you need to add in the training API is this rule called create XGBoost report. So after you add this rule and you call this training API, basically we will wait until the training job completed and also this create XGBoost report rule also completed. And then what we will see is it will automatically send a HTML report to your S3 folder. Also, we will provide a notebook that has the code which generated the report to your XGBoost folder, to your S3 folder. So you can actually run the notebook SageMaker, both Studio and the notebook instance. You can tweak the code. You can see like, okay, what you guys did, like what code you use to generate the visualizations, and more importantly, if you are advanced user, you can tweak the code to generate a customized visualization to your need. So now I'm gonna show you guys what this report actually looks like. So this is the report you will get at the end of the training job for your XGBoost model. So we provide the following visualizations. So we provide, first visualization we provide is a overview of the distribution of your labels in your training data set. As Nathalie mentioned, you could have like some of the problems of a bad model could be related in class imbalance, which is like an imbalanced distribution of labels in your data set. And then we provide you loss versus step graph, because debugger captures the data throughout the training. So you can actually see how is the model learning throughout the training. Like, are you overtraining or are you undertraining? And then we are providing you graphs for feature importance, confusion metrics, and also allowed more information related to confusion metrics, such as like your precision recall F1 score. And more importantly, we also provide you the confusion metrics throughout our training. So not just as a last step, because again, like debugger captures the data throughout. So you can actually get a confusion metrics throughout the training, which can help you learn like how exactly like how each class is learning throughout the process. And we also gave you the ROC curve and also the distributions of residuals. So we can, for this churn model, like we can look at any of this. So I'm basically, it's a binary prediction. So I'm just gonna predict like whether this customer is gonna churn or not. So looking at my distribution of my training data, like you immediately see that, okay, your training data is pretty imbalanced, right? Like most of this is non-churn. And then if you go to your loss versus step graph, we also gave you like explanations, and if you're like a beginner, we give you explanations and suggestions on what to do and what to watch out for from the visualization. For example, for this visualization, we are comparing the training versus validation errors throughout the training process, and you can see that it's not really plateauing, right? So ideally, you should say like your error should be plateauing, but in this one, it's not. So clearly, this model is undertrained. So you should actually increase the iterations to expect the loss to be plateauing. So you have more room for improvement here. And then we can also see the feature importance. We show you like the by weight, by gain, and also by cover. And you got an explanation here, like what each measure is. And like normally like gain is the most relevant one. And again, like you see the confusion metrics, and you also see the more detailed information on confusion metrics, so like precision recall, F1 score. And then there's the accuracy, like which from the confusion metrics, right? Like this diagonal values. So we are showing this throughout the training. The purpose of this visualization is to let you see exactly how each of your class is doing. For this model, like you can pretty much see that your class 0 is not really learning that much throughout the training process, but like most of the improvement is in your class 1. Like, well, for this one, it seems okay because you have a lot more samples for class 0. So the model probably learned very fast from the very beginning. So now, like we also show you, like now let's move to the ROC curve. Like you also see like, and it is actually an interactive model. So you can actually do like all the kind of like zoom in, zoom out to get the exact values. And then we show you a residual distribution as well. So this is all about the automatic visualization feature for XGBoost model. So we just released this feature like a week ago, so we haven't really got time to update our documentation on the website. So we will leave our emails. If you guys are interested in trying out this feature, drop us an email. We will provide you the detailed documentations before this feature, the documentation website is updated. I think the website will be updated on the 14th. So December 14th, you should expect to see the detailed documentation on this feature on our website. In the meantime, I also want to share this video debugging XGBoost model with you guys because we actually like automatic visualization is not the only thing Debugger does for you. For XGBoost model, we also have a lot of rules to detect whether your train, like a lot of the hyperparameters in your XGBoost model, like the tree depths, is good or not, or like whether the model is like loss not decreasing. That kind of rule you can apply to XGBoost model too. So this video actually explains in detail like how do you apply those rules, and also like Satadal mentioned, how do you just analyze the raw data debugger captured? Like this video also tells you how to do that step by step. And that's all I have for XGBoost. I'll hand back to Nathalie.
Okay, great, thanks a lot. So let me see, are there any questions from people?
I don't see it in the chat. Feel free, guys, to ask questions if you have any. Yeah, I just wanted. We are constantly improving and adding more features into SageMaker Debugger, because the fact that debugging is not just confined to training, it's an end-to-end use case, as we know. So keep an eye out. There will be a lot of good announcement coming up at reInvent next week, and December 8th. So there'll be a bunch of new features and functionalities that will be announced. So just a quick shout out to that. If you don't have it in your calendar, you might want to register at reInvent. It's a virtual event this year. And feel free to watch out for Swami's keynote, which is on December 8th from, I think, 7:30 a.m. Pacific time. And thank you so much for your time. Okay, there is a question. There is a free tier for SageMaker. That's absolutely correct. And that has, I can and give you the link to that, but that has a certain number of instance hours that comes with it. So you can try out different features of SageMaker before you fully commit to it. So I'm going to paste the free tier link right here so you can read more about it. Other questions? Looks like we did an excellent job, Nathalie. And Lou. All right.
Okay, thanks a lot.
All right. Thank you so much for your time. Ciao.
Bye.
Bye.